Hello, class. This lesson will be reviewing all of the geometry assumptions and principles that we've been using throughout the course. First one is just saying you have any 2 points, you can draw exactly one line through them. The second one is saying that if you draw a line on the plane, it cuts it into 2 half planes. The third one is saying that we can measure distance. In higher mathematics, that's a property of something that's called a metric space. So these 3 properties together give you a place that you can measure distance in. Number 4 is just saying that you can take any line and turn it into a number line. Number 5 is saying that if you have a plane, you can always find at least 3 non-collinear points. So 3 points not in the same line. So you can always have a triangle on the plane. Number 6 is very important. We've talked about these. We know that basic rigid motions preserve segment length and angle measure. And they also will map lines to lines, rays to rays, and segments to segments. Number 7 is all about angles. Whenever we have an angle that's not a straight angle, or just a ray, its measure is going to be between 0 degrees and 180 degrees. And if we have any ray, if you are looking for an angle measurement using that vertex O, there's only going to be there's exactly one ray that you can draw that's going to give you that angle measurement. So there's only one unique way to draw that angle. C is saying that you can do angle addition. And D is saying that 2 angles that form a line, 2 adjacent angles that form a line, add up to 180 degrees. So they're a linear pair. And the parallel postulate, that's saying that you have a point not in a line, you can draw exactly one line through it that is parallel to the original line. So everything else we've done in this course is based off of those facts. Now, in higher math, we call those facts axioms, and they're just given to be true. Everything else has to be proved from them. And it's been proven that every system has to have a few axioms or unprovable facts, or else the arguments get circular and it doesn't work out. So you always have to have these unprovable things that you just say these are true and prove everything else with that. So here, I want you guys to figure out what should we put in the notes or solutions column for each one. So think about it for angles B and G, and then I'll show you the solutions. So for the first one, they up to 180, 180 minus 133, 47. And this one, they add up to 360, so 360 minus 133 minus 147 gives you 80 degrees. And how did we prove that vertical angles have the same measure? So for example, we did this proof for 4. We said that if we added up the measures of W and X, that's 180, because they make a line. And if we do the same thing for X and Y, those are also 180. So by substitution, these are both equal. We subtract the measure of angle X from both sides, we see that the vertical angles have the same measure. Let's see if we can fill in the blanks on this one. Since that's 64 degrees, what's the measure of angle ABC? Half of that, 32 degrees. In this picture, we have a perpendicular bisector as well as an angle bisector. So what's the length of AC and what's the measure of angle ECD? Well, since we have a perpendicular bisector, these 2 halves are congruent. So AC has to be 12 centimeters. And this is perpendicular, so this is 90 degrees. So since we have a line here, this half is 90 degrees. And the angle bisector is going to cut that 90 in half and give you 45 degrees. You know the interior angles in any triangle add up to 180 degrees. So what's the measure of angle DEB and ACE? Think about that. Well, you know that DEB, that angle, is supplementary to the one that measures 130 degrees. So 180 minus 130 is 50. And these 2 are vertical. So you have a 50-degree angle in here. So 180 minus 65 minus 50, I'll give you 65. And this nice little, we can call it, in higher math you call these things lemmas. This one says that if you have one right angle, and the other two angles have to add up to 90. How can we verify that? Well, you know they all add up to 180. So if one of them is 90, 180 minus 90 is 90. So that's the only possible sum for the other two. Exterior angle is equal to the sum of the measures of the two opposite interior angles, or the two remote interior angles. So how do we do that proof? Well, we said that we know that the three interior angles add up to 180. And you know that these two angles right here add up to 180. So the measures of these three angles equals the measure of these two angles by substitution. And then you ended up just subtracting something from both sides to show that they were equal. You subtracted this angle right here because that was in both equations. So you saw that the measure of angle AED equals the measure of angle A plus the measure of angle C. And we did that proof in a previous lesson, so you can look back at your notes for that. So why do we have an isosceles triangle here? Well, we showed before that angle C measures 65 degrees. So since the base angles are congruent, you know that's isosceles triangle. Here we have a similar diagram, and we want to show that all the angles in an equilateral triangle are equal in measure. So how can we show that we have three congruent angles in here? Well, that's 60. And let's see, we have 120 over here. So these are a linear pair. So angle AEC is 60. We'll go to supplementary. And if these two are 60, 180 minus 60 is 60. So that's one way you can show that all those angles are the same. So since you know all the angles are the same, you know that all of the sides are congruent as well. So that is indeed an equilateral triangle. So we know that when the lines are parallel, we have corresponding angles. Why is it important to say the fact parallel in there? Well, if they're not parallel, then the corresponding angles aren't congruent. Right? So you almost always think of corresponding angles as already having parallel lines, but say you have a line like that and a line like that, you can still have a transversal, but now the corresponding angles are not congruent at all. So here we say that if we have corresponding angles equal in measure, then the lines are parallel. So since it's true in both directions, we can say that this is an if and only if statement. That is, it holds in both directions. If they're parallel, the corresponding angles are equal in measure. If the corresponding angles are equal in measure, the lines are parallel. So this is the only way that that happens, if and only if. And we also learned that same-side interior angles are supplementary. How can we show that, or how can we prove that by having this pair of parallel lines here? So how can we prove that using this diagram? Well, you know that since lines are parallel, that the corresponding angles are congruent. And you know that these two are supplementary. So by substitution, you have that angle GHC is going to be supplementary to angle AGH. And so in this case, we talk about 70. So there's both 70, and this one over here is 110. And so these interior angles are also supplementary, same side interior. And we learned that the converse of that also holds. And how can we prove that using what we already learned about corresponding angles? Well, you know that these are vertical. And so this one over here is 70. Since the corresponding angles are congruent, the lines are parallel. So this, you know, we have 110 degrees over here. And we have a 70 degrees up here. So the original statement holds, it just wasn't written on a diagram. All right, that looks nicer. Okay, so we know that alternate interior angles are equal in measure. What are the names of the pairs of alternate interior angles? How many different angle measures do we have in this diagram? So the alternate interior angles, here are the pairs. How many different measures are there? Well, you know these are both 70. Right, those are vertical. These are both 70 and corresponding. These are both 70 because they're vertical. Or you could say corresponding with the 70. And this is 110. This one's 110 because they're vertical. And this one is 110. You could say alternate exterior or corresponding. And this one's vertical or alternate interior. And so there's only two different measures there, just the blue angles and the red angles. And finally, we know that we have similar properties for alternate interior angles. And why is this also true for alternate exterior angles? Well, if we know that the alternate interior angles are congruent, like the red ones here, then the alternate exterior ones are as well, because those are just vertical angles with the alternate interior ones. So in this lesson, we reviewed our geometry assumptions and the different principles that we proved by using them. Thanks for watching this video.